De Moivre also has a quotient theorem, which tells us how to divide a complex number by another one. And this gets really easy when you understand polar coordinates. Not so easy in rectangular coordinates, but let's go through the polar coordinates of how this works out. You'll see that what the theorem says is if I have eta defined as w divided by z, then the argument of eta, the angle, is just the difference of the arguments of omega and z, of w and z. So what does that mean for us? Well, you'll see I've already filled in the modulus of w and z. Those parts were quick. We've been through that before. And now I'm trying to figure out what the argument of w and the argument of z is in red. And that's the inverse tangent of imaginary over real. Well, for omega, that is -1 over radical 3. So I have to think, okay, I've got imaginary unit circle right here. Where is the tangent value equal to -1 over radical 3? Well, there's two locations. One of them is right here, and the other one is over here. At both of those places, tangent is -1 over radical 3. Okay, well, which one is appropriate? One of them is quadrant 2, one of them is quadrant 4. Which quadrant is this? That's my question. You'll see it's a negative real number and a positive imaginary number. That means we're going left and up. So that is quadrant 2, meaning our angle is right here. Okay, that, if I remember right, is 5 pi over 6. Okay, so that's our angle for w. Now we take the same procedure for z. You'll see this is the inverse tangent of 1 over radical 3 once you simplify this stuff. And there's two places where we get that. There's one, that's 1 over radical 3. There's the other one. So the question is, am I in quadrant 1 or quadrant 3? Well, this is negative and negative. That's left and down. So that is quadrant 3, meaning the angle that I need is 7 pi over 6. Super. So now I have the angles and the moduli for w and z. I am ready to use De Moivre's theorem right here to find out what eta is. Now, the first part is easy. The modulus of eta is always very, very quick. W divided by z is just, let's change colors here, that's just going to be 2 divided by 5. The angles subtracting each other, this is, never mind, I hate orange. It's just not dark enough. There we go. This is going to be 5 pi over 6 minus 7 pi over 6. See those two angles from earlier? So what do we get? I get negative 2 pi over 6. I didn't even need common denominators. That was great. But if you put that in, you're going to be wrong. Right? Look what it wants. Don't forget, it wants your argument between 0 and 2 pi just to keep things friendly looking. So what we have to do here is add 2 pi to this whole thing. I guess I will need some common denominators. Negative 2 pi over 6 is the same as 10 pi over 6. Okay, so that is going to be 10 pi over 6, which you can simplify to 5 pi over 3 if you like. And now the only thing left to do is write everything in polar form. So you'll see the way that works. Eta is just 2/5, right? And then we have cosine of 10 pi over 6, or 5 pi over 3 if you prefer, plus I times sine of, again, 10 pi over 6. Close out the parentheses, and we are done. That is polar form. Now, if you want to change it to rectangular form, take this last step right here. That's easy too. All we have to do is actually calculate what cosine of 10 pi over 6 is. Well, if you remember your unit circle, where is that thing anyway? That is 5 pi over 3, which is like right here. This is what we're talking about. That's my 5 pi over 3 point. So the cosine at that point is equal to 1/2. And I times the sine of that point, well, the sine is negative radical 3 over 2. Okay, so what this works out to be is 1/5 plus, it's going to be a minus, 1/5 minus radical 3 over 5i. So what slowed me down was just distributing the 2/5 times all that stuff. But this is our rectangular